Hi, this is the presentation of the research project. Our supervisor is Wenjin Jia. Our group member including Chao Yishen, Hao Cheng, and Zesheng Wu. First is about the introduction and background of this project. With the rapidly development of IoT devices, there are a lot of companies release their smart devices such as smartphone, smart watch, medical sensors, smart security system, and smart monitor. Also, some internet companies like Google and Apple published their IoT control platform like Apple HomeKit, Google Home, Xiaomi Smartphone, and Amazon Echo. However, because the limit of technology and cost, there are several drawbacks of those platforms. The first is they cannot connect all devices. Most platforms can only support limited brand devices. For example, Apple HomeKit can only connect with Apple Inc. product. Xiaomi can only link with the product made by Xiaomi or Xiaomi. Second, most products rely on the internet. Google Home and Microsoft Azure should connect their cloud service to apply control function. And Xiaomi needs cloud to save data because it cannot save data on local. Third, the platform rely on the internet will increase the risk of cyber attack and data leak. iCloud ever under attack on 2014, and it caused millions of people experience the data leak. Last, there are also many platforms require expensive products to implement the device's control, such as ARKit, Mindsphere, and Apple Home. Considering this issue, we think there are four main requirements about the IoT control platform. They are convenient, cheap, compatibility, and security. So we aim to design and develop a new IoT control platform which can not only access via the internet but also avoid the risk of the internet. In addition, this product should be cheap, safety, and convenient. So we design a function which can demonstrate this demo. A personal monitor function. The monitor can monitor a special area like the house door and upload data to system immediately. If system notices someone appear on the screen, it will save image and send a message to user. Also, user can load this image on his smartphone or tablet or PC. This function demonstrates our demo has remote access, data saving, data uploading, and remote control. In order to imply this function, we need to select the storage solution first. There are three main storage solutions: NAS, DAS, and SAN. DAS is basic and cheap. DAS is basic and cheap solution. It's directly and it provides high-speed storage, and also it's neither low maintenance required, but it's legal flexibility and data sharing ability. So it's suitable for small business and home environment. NAS has expansibility and it provides good performance, data sharing ability, but it needs maintenance, it requires network, and it requires a devices supply. So it's only suitable for small and mild business and home environment. SAN provides the best performance in service, and it has flexibility and reliability. Also, it has the data sharing ability. But it needs high maintenance, it requires high-speed network, and high invest. So, SAN is only suitable for big organization and data center. We think NAS is the best choice of this project. Also, we compare the advantage and disadvantage of different types of hardware. PC has the best performance, scalability, and development capability. The price but the price and energy consumption are far higher than single-board computer. Therefore, it's not suitable for longer standby or running time usage. For similar reason, smart tablet is expensive at the same time, regardless of iOS system or Android system. Tablet were limited in development environment, obviously. Microcontroller and single-board computer is the most suitable for such design requirement. Also, we considering the performance, price, development environment, and development resource. We think the Raspberry Pi is the most suitable hardware for this project. Thank you.
Thanks for Chaoyi. At first, I want to discuss about the protocol of file system. NAS needs a file system on device. It is necessary to select a file system installed on Raspberry Pi. There are three main file system protocols: SMB, NFS, and CIFS. SMB is a file sharing protocol suitable for Unix and Linux. It allows the computer to read and write files to remote host over local network by sharing. It is relatively more flexible and compatible with different system platforms in new version. CIFS is similar to SMB protocol, but they have different performance and implementations in file locking, less modification of file, and other differences. NFS is distributed file system protocol in Unix. Developed by Sun Microsystems, it allows users access files through network to other computers. When a device mixes Windows and Linux, using NFS will cause the Linux client and server connection to be disturbed. CIFS is not suitable protocol because most modern storage systems no longer support it. SMB has a better security solution. Therefore, we choose SMB as the primary protocol in the file transfer. Next, in order to complete a NAS system, there are some main media standards to consider. Media playing is one of the major functions in NAS system. Using specific media display standard can carry out the media function. Then other devices like smartphone, TVs, PCs can open media data from NAS. DLNA is a simple way to play media files between two devices after simple setting on source's device. All sharing documents will be available on other devices under the same local area network. Despite the DLNA allows to open local media files, it cannot play in the stream media from internet directly. It should be downloaded and saved on the source device. AirPlay is a wireless display standard created by Apple, which allows users to stream video from one Apple device to other Apple device. However, it only serves Apple products. Miracast is widely used in industry area. It can support both Android and Windows systems. In fact, it doesn't perform very well because of compatibility. Chromecast allows the smart device push video files to screens quickly, but same as AirPlay, this standard only push data to specific receivers. Considering this demo to be developed based on the Raspberry Pi, the middle standard should be compatible enough to play on much device. Obviously, DLNA is the most suitable. Then let me introduce the Internet Penetration tool. FRP is a higher performance reserve proxy application developed in Go. FRP supports TCP, UDP, HTTPS, and other protocol types, and supports websites to forward based on the domain name. The role of FRP that help you expose all HTTP and HTTPS service behind a net or firewall to the internet through a server with public IP address. In terms of settings, the NGR code setting is too complicated, but the FRP is simple. What's more, the current FRP is very stable. In terms of software, in order to accomplish functions, it is required installing software on Raspberry Pi and a smartphone. PhotoSync is a photo management application which can upload all pictures saved in phone to PC or NAS. Using this application, it can back up data automatically when the phone connects the specific network. In this demo, PhotoSync can back up photos to NAS via FTP and transfer video via SMB. The disadvantage of demo, the current product is still somewhat inadequate. First of all, we don't have our own app interface, so we need to use the third-party software when using our phones, such as use PhotoSync when upload photos. We hope to design a special app interface in the future. Next is Zhequan's part.
That's for Haochen. Now I'm going to talk about implementation. According to the evaluation of hardware, Raspberry Pi is an ideal hardware platform. Raspberry Pi is cheaper than traditional PC and has better performance than Arduino. The following figure is the general framework of this design. We can back up our photos, videos, or something else to the NAS which is located in a local area network. We can also share this multimedia with other people through NAS. We can play these videos which are stored in the NAS without downloading them. And the camera is controlled by Raspberry Pi. It will take a photo when someone appears in front of it, and then Raspberry Pi will send me an email to tell me that there is a new photo. We can check this photo on phone or on other devices. Then I will show the main changes in this project. The Raspberry Pi is in a local area network, so we cannot access it when we are not in the same network. AWS is a service provided by Amazon to help us build a server. It provides us a public IP address. We can see this IP address here. And the problem after having a public IP address is how to channel between Amazon servers and the Raspberry Pi. FRP is a very convenient tool for network penetration. We download FRP on Amazon and modify the configuration field to set it up as a FRP server. The picture on the left shows us the configuration of FRP server. The port number is set to 7000 by default. The token is the key used to establish a connection with the client, and we also download FRP on Raspberry Pi and modify the FRP client field. Server address is a public address provided by Amazon AWS. We fill in the domain name of AWS here. The port number and the token need to be consistent with the configuration on the server. So the FRP penetration is completed. Users can access Raspberry Pi in an external network now. Some port mapping are configured here for different functions. For example, configure a model named HA when a user accesses port 443 on Amazon servers. He will be able to access ports 443 on Raspberry Pi. Port number 443 is used for the admin page access for Home Assistant, and the port 1003 is used for FTP transfer, and the port 8888 is used for file management platform. After that, we apply a free subdomain for our server. Then we can access Raspberry Pi through this domain name. And this is the file management we use to modify configuration of Raspberry Pi. We can use domain name with port number to open it. There are some basic configuration of Home Assistant. We can add some other sensors here in the future, then we can control them through Home Assistant. In conclusion, we designed a IoT platform which has the function of NAS based on Raspberry Pi. It is cheaper than other NAS on the market and better screen performance than cloud. In the future, we will add other sensors to this IoT platform. We expect to use a Raspberry Pi to control all other devices at home. And this is our reference. Thank you.